2 times 2. Okay, we have a common ratio. That's the b value for an exponential. So this is an exponential. We have our b value, it's 2. I need our a value, that's our initial value or our y-intercept. So I can look at the table and I actually see the y-intercept is here. So the a value is 8. So when we put this as an exponential, it's y equals 8 parentheses 2 to the power of x. Exponential function, bit of a throwback back to January. Okay. On to the next. Same style question, linear, exponential, quadratic. Now at a glance, I'm assuming this is a quadratic that has a vertex at 0, 0, but I'm going to confirm by looking for a second difference. So second difference, from 8 to -2, we're increasing by 6. From -2 to 0, we're increasing by 2. From 0 to -2, we're subtracting 2. And from -2 to -8, we're minusing 6. So those are our first differences. Now I check the second difference. From 6 down to 2, that's -4. From 2 to -2 is -4. And from -2 to -6 is -4. So the second difference is constant. So that checks out. This is a quadratic. And we're going to write the function. Well, I have a vertex. So I'm going to put this in vertex form because that should be pretty straightforward. Y equals a x minus 0 squared plus 0. Well, I don't need this and I don't need this. So this is y equals a x squared. I do need to solve for the a. So I'm going to go get another coordinate. Might as well just use this one. So I'm going to plug 1 in for the x and -2 in for the y. So we have -2, 1 in for the x, so that's 1 squared. A, -2, 1 squared is 1, so a is -2. So your function here is y equals -2x squared. If you put it back into the vertex form, remember that's where those had zeros, so they just dropped out. Okay. Moving forward, number 10, you are playing table tennis with a friend. The path of the ball after you return a serve can be modeled by this function, this quadratic function, where x is the horizontal distance in centimeters from where you hit the ball, and y is the height of the ball above the table. What's the maximum height? So the maximum height is the vertex. This is standard form. There is a little formula for finding the x value, the axis of symmetry, the x value of the vertex, and then the height's going to be the y value. But first we need the x value. So we're going to come over here to the margin. We're going to use the formula, the opposite of b over 2a. So the b is 0.2 over 2 times -0.001. If you're not so good with decimals, feel free to use a calculator. Well, that should be negative because it's the opposite. Good. So -0.002. So I'm going to go grab my handy calculator, a handy TI-30, and 0.2 negative divided by 0.002, again negative, x is 100. Remember, that's the horizontal distance. I want maximum height. So now I have to input this into my function and evaluate for x equals 100. So we're going to come over here. Y is negative 0.001 times 100 squared plus 0.2 times 100 plus 10. Again, we're going to do some calculator work. We're going to do 100 squared, following order of operations, 100 to the second power. It's 10,000 times 0.001. Make sure to make it negative. So that's negative 10. 0.2 times 100 plus 20 plus 10. Negative 10, positive 10 cancel. Equals 20 centimeters. So the maximum height of the ball is 20 centimeters. On to number 11. Write a quadratic function in standard form whose graph has a vertex of and passes through. We could use either intercept form because we're given intercepts, or we could use vertex form because we are given a vertex. I'm going to use intercept form. It is perfectly fine to use vertex form for this, but I prefer the intercept form. So f of x equals a. These are our intercepts. X minus 0, so I'm just going to put x, and then x minus 5. Now I have to go solve for a. So bring in the vertex, so 5 equals a, x, 2.5, and then 2.5 minus 5. Okay. We're going to do a little bit of this on the calculator. I'll do this parenthesis simplify. Should be 2.5 minus 5 times 2.5. That's negative 6.25a, and that means a has to equal, if I divide both sides by the negative 6.25, negative 0.8. You are also welcome to convert that to a fraction, which your calculator will do for you. So we can go second and then the back arrow for FD, and that is negative 4/5. You could use either of those. I'm going to use the decimal, but both are acceptable. And now we need this in standard form. So we have f of x equals, we have an a value, negative 0.8 x, and then x minus 5. I'm going to distribute the x first. F of x is negative 0.8 x squared minus 5x, and then we're going to multiply the negative 0.8, so f of x equals negative 0.8 or negative 4/5 x squared times negative times plus 4x. There's your standard form. Negative 0.8 or negative 4/5 x squared plus 4x. Okay. Choose a quadratic function in standard form whose graph passes through. Well, this is a 0, so I'm going to go figure out what are the factored form of each of these. I'm going to convert these to intercept form because I do notice that each of these is going to turn into a binomial squared. So this is x squared plus 3 squared. This is x plus 4 squared. This is going to be x minus 3 squared. And this is x minus 4 squared. So this is going to be the only one that passes through 4, 0. to 13. The creator of two apps records the number of downloads over time. We've got app A, we've got app B. So from week 6 to week 8, which app had a greater average rate of change? So from 6 to 8. So from 6 to 8 and from 6 to 8. Well, I'm going to do the table first. We use the standard slope formula, the rate of change formula, y2 minus y1 over x2 minus x1. So that's 1150 minus 900 over 8 minus 6. I can get a little calculator. 1150 minus 900. 8 minus 6 is 2. So that's 125 average rate of change, 125 downloads per week. What we notice here is at B is downloads per day. Pretty sure that's just a typo and that's supposed to say week. Doesn't actually change the answer one way or the other, but that's supposed to say week. That's a typo. So I have to kind of estimate what this ordered pair is. So this looks to be approximately 6, 400, 600, maybe 700, maybe 675. It looks like it could be 675. And then this looks to be 800, 1,000, right under 1,000, maybe 975. So this looks maybe 975. This is going to be an approximate. So 975 minus 675 over 8 minus 6. So that looks to be about 300. 975. You can calculator that to confirm, but that's 300. Divide by, again, 2. That's approximately 150. Well, that's enough to say that app B has the greater average rate of change from week 6 to week 8, which will eventually have the greater number of downloads. So we know that this function is either quadratic or exponential because it's nonlinear at curves. Well, let's see if we can tell what this function is. This is an increase by 250. This is an increase by 250. And it continues to increase by 250. So this is linear. So at B will have the greater number of downloads. And the explanation is because it's either quadratic or exponential. You don't actually have to tell which one's which because the other one is linear and at A is linear. At B is going to have a increasing rate of change because we continue to get closer and closer to vertical, so the rate of change gets higher. So eventually the rate of change in at B exceeds the rate of change in app A. So the linear one is always going to be bottom of the pack eventually. Well, there's number 1 through 13. Number 14, I've provided the answers for you as part of the assignment on Canvas. So you can go get those answers and look them up. I hope this has been an informative and helpful review for the material before we take our unit test tomorrow. Have a great rest of your week.